The next step is to determine what logic symbol or symbols that we will use to create our lighting scenes. Since we know that the lighting device is an analog device, we need to use analog logic to program it. We will navigate to Analog Operations and choose the analog symbol called Analog Preset to evaluate it and see if it will do what we need. All logic symbols have speed keys or shortcuts to add them to the program. The analog preset speed key happens to be the word preset. Select the folder where you want to put the preset, in our case, the lighting folder. If we type preset and press enter, it will add an analog preset to the program. You can also type preset : and the name to prename the symbol. The more you program, the more you will learn the speed keys for the most common logic symbols. If we look at the analog preset, we can see that there is a single, non-expandable digital input and expandable analog signals on the right, a parameter in the middle, and a ramp time parameter on the bottom. We'll open up the help file and see what the analog preset can do. The digital input called trig is an edge-driven digital input. This means it needs a pulse or a rising edge to activate. The input causes all analog outputs to ramp from the current values to the corresponding level pound values on the rising edge of the input. During the transition, a second rising edge of trig will cut all outputs to their final values immediately. This means if a user presses the button once, the values ramp based on the time parameter. Press it twice and it cuts immediately to the final value. There are up to 999 outputs possible with this logic symbol. For example, if the parameter says 100%, the analog output will ramp to 100%. There is a single precision parameter for the level. For that parameter, we can choose the numerical formats option to see what we can use. We can, for example, use decimal, hex, percentage, and others. We cannot do time in this case because we are trying to represent a percentage in some way. The parameter called ramp time specifies the time it takes for the analog outputs to transition from their current values to the target values. All outputs share the same ramp time, and thus all outputs reach their target values simultaneously. If we use a ramp time of 4 seconds, it will take 4 seconds to get to the value. In this example, we will use the analog preset to set a lighting scene. Since we do not have expandable inputs, we will need to use a separate analog preset logic symbol for each preset. We will start with lights high by dragging and dropping it onto the input. We will define it as 80%. The output will end up going to the light, so we will name it lights.level. There are two places that we need to connect the analog output of our preset to. The first is the output to the gauge itself. The second is to the dimmer to control it. We will connect that now to the dimmer. To connect it to the gauge, we will open our X panel and choose Analog Feedback Join 1, since this is what is already defined in our display project that is running on the X panel. Now we need multiple analog presets. There are many ways you can do this. You can click and drag them from the left, or you can use the speed key. We will name the preset we already have Lights High. We will create another analog preset by entering Preset and pressing Enter, and name it Lights Medium. The Lights.medium signal from the Smart Object will go to the trigger of the new analog preset. The ramp time will be 4s to signify 4 seconds, and the percentage will be 60%. All our presets will be manipulating the same lights.level signal on the dimmer and the X panel. There is only one light load in the system, but we want to be able to send it different values at different times. When an output signal is used twice in this method, it is called signal jamming.